Yes, dear students, in this video I am going to define acceleration. Very important topic and unfortunately misunderstood. Acceleration. Actually, our chapter is motion. So, in which motion there is acceleration. Whenever velocity of body changes with time, then we say there is acceleration. If velocity of body in a motion is changing, then we say there is acceleration. And therefore, acceleration is defined as change in velocity per unit time. In maximum books I have read the definition rate of change of velocity. That change may take place along with distance. Here the change with time, and therefore we must say directly that acceleration is defined as the change in velocity per unit time. Don't say rate of change of displacement, rate of change of velocity. Change of velocity per unit time. I stressed the acceleration is there only when velocity is changing, and change in velocity taking place per unit time is acceleration. Now this simple definition there, but now how to explain further? Let Vt1 velocity, vector Vt1 and vector Vt2 are the velocities of a body at time t1 and t2, time t1 and t2, then average acceleration of motion is given by A average vector. Acceleration is a vector quantity, so we must use the notation of vector here, equal to Vt2 minus Vt1 upon T2 minus T1. Well, vector A equal to Vt2 minus T1. There is a meaning here of writing like this, overwriting. I am writing again. Average expression A equal to A average equal to Vt2 minus Vt1 upon T2 minus T1. Here this has a very good meaning in writing this way. I will tell later on. Or A average equal to, we write delta V upon delta T. Delta V means Vt2 minus Vt1 and delta T, T2 minus T1. Means delta V is the change in velocity in time interval dt. This is average acceleration. Now we want instantaneous acceleration. Now you are very clear about this thing. Instantaneous. Acceleration is again average acceleration, average acceleration, which is taken over a very small interval of time around the time at which we are determining the acceleration, that is a equal to limit delta t tending to 0 delta v upon delta t, which we write it as a equal to dv over dt. dt the small interval of time in which change in velocity is dv, in which velocity is dv, and further you know vector v equal to dr upon dt velocity. So we can write a equal to as d upon dt of dr upon dt. V equal to dr upon dt and a equal to dv over dt. So in place of v we use, and mathematically we write in notation has been done d2r over dt square. Double differential of position vector gives us acceleration. Now I am coming here again. What is the purpose of writing like this? Unit of acceleration in MKS and SI system is meter per second square or meter second minus 2. This should be small s. In CGS you can write centimeter per second square. That is not so difficult thing. But what is important here? Acceleration, I have marked a vector quantity. Direction of acceleration. Here there is lot of confusion. How to tell direction of acceleration? Student tell in the direction of motion of the body. No, not at all. It is not necessary that acceleration will have the direction of velocity in which it is moving. Actually, V average is V2 minus V1. Change in velocity per unit time. So, direction of Vt2 minus Vt1. This will come out a vector. Difference of two vectors is again a vector. So direction of Vt2 minus Vt1 is the direction of acceleration. Is the direction of acceleration. Please listen this very carefully and try to understand. In class, when I was a student of class 11, I was confused how the acceleration may be opposite to velocity. Actually, acceleration is not velocity, it is change in velocity. If body is moving straight path, then you can think, suppose it is vector v1. and then it get increased to V2. How do you subtract factors? V2 minus V1 करना है. This is V2 and this puts the tail of V1 on head of A and drew in minus direction. It is V1. This whole is V2. So our V2 minus V1 comes this way only. So here direction of acceleration is along delta V, which is along velocity. But if anyhow V2 vector is smaller than V1, this is V1 here, this is V2 here, then V2 minus V1 will come out like this. So delta V now opposite to the direction of motion. So now acceleration is opposite to velocity. If body moving on a straight path, it is the case. But if body not moving a straight path, by motion may change direction, it is V1 here, it is V2 here. You have to find out direction of acceleration is change in velocity. So V2 minus V1, this is V2, this is minus V1. So you will get this direction. So now delta V neither along V2 nor along V1. So direction of acceleration is along change in velocity. This topic has to be understood very well, otherwise you will be in trouble in coming chapters. I have noticed and I myself felt lot of difficulties because of this change of direction of acceleration. Direction of acceleration, and acceleration means change in velocity, not velocity. Change in velocity per unit time is acceleration. So if you have any problem, you can write in comment. I keep on observing my videos. If you feel any difficulty and you don't understand, then you can write in comment. Then I may respond accordingly. And I request you to subscribe my channel and share it with other also, because I know I have a very vast experience and I learned this physics very well and got it very well. I see people are teaching other way also. I don't want to criticize anyone here, but there are many problems. Many topics are totally taught wrong. Like this acceleration, I got many books. I was forced to prescribe a book in school and asked the principal to prescribe. And that book having 3 chapters, one for displacement separately, another for velocity, and third one for acceleration. But direction of acceleration was not defined at all. It was told acceleration vector quantity. If a quantity is a vector, then you have to tell the direction and you have to understand that direction. Thank you. मिलते हैं.